No matter where you are on our planet, whether you're in the big city or in the middle of the countryside, a new world opens up when you look up to the sky. Dotted with light from afar, the dark abyss above us inspires us in ways like no other. Today we're kicking off a new series on the ins and outs of the place we call outer space. Over the next 4 weeks, I'll take you through some of the most compelling questions we have about the universe and what we still have to learn. Let's start things off from a quiet corner of a small country almost as north as you can go. Finland is known for its forests, and it's known for its silence too. What you may not know is that where we are, these traits give us an edge in the quest to learn something new. Welcome to Metsähovi Radio Observatory. Hi, I'm Kate from Aalto Communications, and this is our new 4-week series on research touching outer space. We're coming to you today live from Metsähovi Radio Observatory, which is about 40 kilometers west of Helsinki city center, the capital of Finland. I'm sitting here with Anne Lähteenmäki. As you can see, we're a little bit bundled up because we're sitting under the radome, a large dome that protects the radio telescope behind us. So while we're protected from the rain and the snow outside and also the wind, it's a little cold in here. Anne, thanks so much for having us here. It's great to be at the Radio Observatory.
Thank you.
Can you tell me about the kind of work that's happening here at Metsähovi?
Well, what we have here is a radio telescope, which is a big dish, a 40-meter dish, that we use for radio astronomical observations of active galaxies and the Sun. But we also construct instruments and design software for astronomical research. But mostly we do these scientific things with the telescope.
Okay, and how many people are working here at the observatory?
We have about 15 people that work here every day, and then of course we have collaborators all over the world who also use our data.
So this is really an international initiative in a sense.
Absolutely, because nowadays you can't really do astronomy on your own. You need to have a collaborator network because you can't really use just one instrument for your observations. You will need observations from lots of different kinds of frequencies to get the whole picture.
Right. Then that leads me to my next question. What is a radio telescope and the radio waves that it picks up? What are those things?
Well, electromagnetic spectrum actually consists of radiation from lots of different wavelengths. We start with the radio, which is the longest wavelengths, and we go through optical to infrared, X-rays, gamma rays, which are the shortest wavelengths. So we're doing radio observations here, which are lower frequency than optical observations. And optical is, of course, what you can see with your eyes, but you can't really see radio waves with your eyes, so you need to have a specialist equipment to detect.
Right, so we're not talking about the kind of telescope that you'd have in your backyard.
Well, you can also have an amateur radio telescope if you want, but normally people have optical small telescopes.
Yeah, which shows the sky, the stars in the sky and so on.
Yeah, exactly.
Yeah, so you're gathering data with this.
Yes.
Yeah, and you're gathering data every day of the year.
Yes, we can use radio telescope basically 24/7 because we are not limited by daylight like optical astronomers are, so we are quite privileged in that sense. We can even do these observations during the day.
Yeah.
We are slightly limited by weather. If it's snowing, for example, we can't really do observations here at all.
Right. And so when you're looking at radio waves, and it's filling in part of the picture, right? Mm-hmm. So you're looking at galaxies. What is something that radio waves give you that other frequencies don't?
Well, there are several benefits to radio waves. I mean, one, for example, is that you can see through dust. With optical wavelengths, you're always obstructed by dust. For example, in our own galaxy, you can't see through it. For example, the center of our own galaxy is completely obstructed by dust in optical wavelengths. But with radio waves, you can actually see through the dust and what's behind it.
Well, that's quite handy.
Yeah. And of course, the biggest thing is that you can do observations of the active galaxies with radio telescopes.
Right. And when you talk about an active galaxy, what do you mean?
Well, what they are is that they're very distant galaxies They do have stars like normal galaxies, but active galaxies are exceptionally bright at some or many other frequencies as well. And this is because there's a supermassive black hole in the very center, and there's an accretion disk surrounding the black hole. And then what happens is that relativistic jets, meaning that particles move at almost the speed of light in these jets, are ejected from the close to the supermassive black hole. And these jets are the things that we can see with the radio telescopes because they emit radio waves.
Okay, so everybody's familiar with the black hole. Maybe not everyone's familiar with one of these jets. So how big is it? How important is it to the system?
Well, in active galaxies that emit radio waves, the radio jet, I mean, it is really one of the most important parts of the whole galaxy that we study. If we think that, for example, a galaxy like the Milky Way is about 100,000 light years big.
Pretty big,
yes.
I would say.
And well, other galaxies about the same size or even larger, but the radio jets are so large that they can go outside the host galaxy even 10 times. So they are massive, that they push through the galaxy and just extend beyond to the intergalactic space.
Okay.
So they're big things.
Yeah, and very powerful in a sense.
Yes,
yeah.
Especially in sort of evolved old elliptical galaxies that produce these massive jets as compared to some other things that we're going to discuss a bit later, I think.
Yeah. So you've been working here for some time at Metsähovi.
For a very long time, actually, since 1990.
1990, okay.
Yeah, I came here as a summer trainee to do observations.
Okay, yeah, so you've really seen this place evolve and
Yes.
gotten to know the area for sure. And I know that you've been studying certain kind of galaxies lately over the last few years that haven't gotten a lot of attention from other sources, other scholars interested in the phenomena. And I was wondering if maybe you could talk a little bit about that. So what got you interested in that? What caught your initial interest? And what have you been finding?
Okay. So the kind of active galaxies that a lot of people are studying are one of those really powerful ones that are called actually blazars. And because they're so powerful, they're very easy to observe, for example, with radio telescopes, because you get lots of data for them. But there are several fainter types of active galaxies. And of course, because they're faint, they are not being observed so much because you don't get so much out of them. And there are even some active galaxies that have been thought that are completely radio silent, which means that you don't get any radio emission out of them at all.
So they're quiet ones in the classroom.
Yes.
You don't notice them.
Yes. Well, they might be actually quite bright at the optical.
Okay.
But not bright at radio.
Right.
And if you don't see radio emission from them, what you usually think is that they can't have radio jets because, I mean, obviously, if they have radio jets, you would observe them at radio. But if you don't, well. But actually what happened a few years ago is that we got this idea that these special kind of galaxies that we call narrow-line Seyfert-1 galaxies, that they might actually have sort of very small baby jets because they're young objects that are just starting to evolve. So we wanted to take a look at a sample of these just to make sure, are they really radio silent or do we see something?
Yeah.
And it was a bit of a surprise that we actually were able to detect quite a few of those.
Okay, so other people had found that they're not doing anything.
Exactly. The problem here is that sometimes you define these sources in one survey that happens 20 years ago, 30 years ago, and nobody looks at the same sources ever since, and they are sort of wrongly classified for decades. And then somebody, stupid radio astronomer, comes and says that I want to look at radio silent sources with a radio telescope. And this is what you get then.
Yeah.
A nice surprise.
Yeah, a nice surprise for sure. And you've been finding this consistently over the last few years, is that right?
Yeah, we started the project 2012
Yeah.
with just 30 or 40 of those sources, and now we have hundreds that we are sort of trying to look at whether we would find more of these interesting ones.
Right. So you're actually tracking these over time.
Yes, exactly, because active galaxies, the bright ones and the faint ones, they are changeable objects. They are not static. They do interesting things. They vary. And that's because the radio jet in them is doing things. It's sometimes a bit brighter, sometimes a bit dimmer, and that has got to do with its interaction with the supermassive black hole. So when we're studying the radio jets, we're actually studying the supermassive black hole at the same time.
Right. So when you talk about the supermassive black hole, what kind of exciting things are you finding with that?
Well, there are several things that you can sort of take a look at. We don't know so much about black holes yet because we can't observe them directly.
It's a bit difficult, isn't
Yeah,
it?
it is. But we can sort of observe how they affect their environment. For example, by generating these radio jets.
Right. What about baby jets? I know that this is something that you've talked about before, that when that things might come in different stages, they develop in different ways, and
Yeah,
you're able
exactly.
to study.
Yeah, these sort of silent sources that we were able to detect, they are spiral galaxies, and you usually think that spiral galaxies are young galaxies.
Okay, and why is that?
Well, because they are sort of the first stages in the galactic evolution. If you put two spiral galaxies together, because sometimes they meet in space and they merge, and what comes out is an elliptical galaxy, which by definition is then an older, more developed galaxy. And so the spirals came first and the ellipticals came from these mergers. And it's usually been thought that spiral galaxies can't produce radio jets because they're sort of small and in the early stages of their evolution. And now that we're actually observing these baby jets in the spiral galaxies, we have actually been able to prove that yes, spiral galaxies can produce jets as well.
Yeah.
And that's a new thing in a sense that when you try to put together a kind of evolutionary sequence of galaxies, how they evolve from the babies to these mature old big things. This is actually an important step because now we know that already at this particular stage they can produce these jets and become sort of fairly powerful.
Right. So you're actually looking at how these galaxies are growing up, how they're maturing, developing, and becoming something much more powerful.
Yes, exactly.
Yeah. So I suppose it's needless to say that this is a very exciting line of research. I suppose that, like you were saying, you're studying them over time, that one observation is not enough.
Definitely not. I mean, that is one of the big problems in the older observations of these sources, that you just take one data point 20 years ago and then you sort of presume that that's what it is and it will never change. And we have already seen many times also at this observatory here that it's not true, that you have to follow them up because things happen, things change. The radio jet there, it evolves and it changes all the time.
Right.
And it's really impossible to try to do any science out of these sources if you don't have that constant monitoring of what they're actually doing. Because what we do is that we take the data and we try to fit them into models. And if you don't have enough data to put in, your models don't work.
Yeah. So it's a long-term initiative. It's a lot of work. It's with a team, I'm sure. And you've been working with people. I know that you've published a paper recently in the last year or so exactly on this, the development.
Yes. Well, I mean, in general, the way, for example, our observatory works is that we collect radio data at our frequencies, high radio frequencies, and then we have lots of collaborators, usually abroad, that collect data at other frequencies, and we put together everything that we have so that we would have a complete picture of this source at all of the frequencies that we can just get. And then we put the data into these models and we see what comes out, and then we write a publication of that with our collaborators. And of the project that I'm doing now with the fainter galaxies, we have published several papers last year about the radio silence as well, and also the first doctoral dissertation was done
Specifically
last
on
year.
this topic,
yes,
right?
Exactly,
Yeah, that's
based
exciting.
on these observations at Metsähovi.
Excellent. Yeah. I know that at Metsähovi, it's a really exciting place to be, and when I've been able to visit, it's been really nice to see everybody buzzing about, and also come in here under the radome. It's an exciting place to be because you realize just the scope of what's going on. We're sitting here in front of the large radio telescope, and it's active all the time, like you mentioned.
Yeah, it's observing at the moment.
At the moment, yeah.
Yes.
So if you hear a little hum, then that's what it is.
Yeah.
And we hear a little bit of the wind hitting the radome right now,
Yeah.
because it's winter and this is Finland. But what I've understood is that there's a very unique way of working here that makes Metsähovi, or the pumpkin, as I've understood.
In Finnish.
Yeah, kurpitsa in Finnish. The pumpkin has a unique way of working in terms of the atmosphere and how people come together. And I wanted to talk a little bit about that. So how Metsähovi differs from many other radio observatories around the world.
Well, actually in many ways. What you said is that we are quite tight community. We work really well together and we produce lots of results, even though we are a very small unit, so to say. But also the way we work as an observatory is different, because usually if you want to do observations with a big instrument like this, you have to apply for the observing time, which means that you have to send in an application and tell why do you want to make these observations, and then somebody somewhere, a committee usually decides whether you get that observing time or not. But here we have the whole telescope for ourselves. We can use it for our projects, so we have a lot more observing time than I would say any other radio observatory in the world. And this has also enabled us to do these kind of projects that I have described today, because we have the observing time to look at hundreds of sources and look for those really interesting ones.
Right. So you're actually able to look at things that you otherwise might not be able to look at.
Yeah, exactly, because we have the telescope for ourselves.
Right. And I suppose that's something that you've been able to benefit from by building your career here.
Yeah, exactly. I have been working here for quite a long time, as you heard, and I did my doctoral dissertation here as well. And then I took part in the Planck satellite project, and our observations here have helped immensely to get into these international big things, and sort of we have a very good reputation internationally.
Yeah, I bet, based on everything that you're finding and everything that you've been involved with.
Yeah.
So I know also that there's a lot of changes that are coming up in the next year or a little bit longer, that there's investments coming into this facility. And
Yes, very positive changes.
Yeah.
Well, the first thing is that the radome that surrounds the telescope, it needs to be replaced every now and then, because the weather is not very nice to that. It can be quite harsh.
Weather's a bit harsh sometimes.
Yes, so it needs to be replaced. So we're going to get a new radome, and we're also going to get a new building, because we are also getting more students that work here at Metsähovi, hands-on doing things and projects and studying.
Right, right. Oh, and now we can hear the telescope moving around.
Yeah, it's going to its next source to do some more observations.
Yeah, so when it moves, how far does it actually go?
Well, it can go entirely around 360 degrees.
Yeah.
And we can usually observe from something like 20 degrees up to 60 degrees in elevation. So it can just reach any part of the sky that we need to look at.
That sounds quite nice. I guess nowadays you don't need to be here in person 24 hours a day.
Not necessarily. We can do some of the observations remotely from home. We have some good system nowadays that we can control the things, and we can also follow the weather, because that's quite important when we do observations, to make sure that everything is working properly. But there are some things that we still have to do here as well, because we have the radome and we have weather, and sometimes we just need to really be here to make sure that things run smoothly.
Right. One of the things that sets this place apart from normal working environments, so for example the main campus of Aalto University, is that when you enter the grounds you actually have to turn off your phone. You have to turn off all Wi-Fi connections with your laptop.
Yeah.
You're a little bit disconnected from the modern world in a sense. I mean, or at least you have to plug in. And how has that been working here at Metsähovi? In a little bit, it's a beautiful area. We're in the countryside, in the middle of a forest. It must be nice to work in this kind of environment.
Yeah, it's really nice. I mean, you get to officially you have a permission to turn your phone off
Yeah.
when you come here. I mean, we do have landlines, but we get lots of radio interference from mobile phones, and that's why we have to switch them off, because we don't want to interfere with our observations. But I think everybody who's working here thinks it's a very good thing, actually, so that you can leave something like that behind and concentrate on your work.
Yeah, I can imagine it's very conducive to working and getting things done, and it's also very peaceful here.
But also it can be a problem because there's so much wireless things in the world nowadays.
Yeah.
As you mentioned, laptops, but there are also lots of equipment in cars nowadays that send radio interference. So it's a battle against that as well. And in some of the radio observatories in the world, some of the frequencies have actually been destroyed because of
really?
this exterior interference.
Yeah. I remember when I visited here the first time, you showed me a screen which showed that there had been some kind of external interference, that you're actually measuring for that.
Yeah,
at the
we
same
monitor
time.
the radio interference that we get here, so that we sort of, we know if somebody has forgotten their mobile phone on, then we can go and tell them, please switch it off.
Right.
And we also can maybe see if there have been problems with observations, if there's a reason for that.
Yeah. What about students? You have students coming here to study in the summers, and
Yeah, well, Aalto University has a major for space science and technology, and radio astronomy is part of that. So we have different courses actually, and one particular course on radio astronomy. And students can come here and do observations with the radio telescope, and they take a look at the receivers and learn about those as well. And then of course we have student projects. We actually have a plan of building the first interferometer in the Nordic countries. That means that we have several small 5.5 meter telescopes that we are going to set up to work together. And this is interferometry, when you have several small telescopes, or large ones, and you set them up to work together. This will require a lot of work, but we have student projects available for students who want to design some of these things, the telescope, operating systems and receivers. And as soon as we get a bit more funding for that, we can really start working on that as well.
that sounds really exciting. So the students can also get involved with how this place is developing.
Yes.
Yeah.
I mean, that's one of the main things that we are here for. We also want to educate and teach students to become, hopefully, radio astronomers in the future.
Oh, most definitely, I'm sure. All the things happening here. I think we're starting to run out of time, but I wanted to thank you, Anne, for hosting us here. It's been really great talking to you. I think this place is very inspirational to many. We can learn so much from the work being done, especially the stuff about looking at a phenomena that maybe isn't immediately so interesting or immediately so obvious, that it's worthwhile taking the time, having the resources to actually be able to look at those things a little bit more closely. And I think your work really testifies to that fact, that how important it is, because you've been able to learn so much about galaxy development.
Yeah, and it's very sort of motivating for me as well, because this is my dream job. I've always wanted to be a radio astronomer, so I'm in my dream job, yes.
That's wonderful. Well, I think that with that, I want to thank you again for hosting us here at Metsähovi and for being part of our first Way Out There episode. I want to thank the crew for being here with us today in the cold. And I want to remind everybody that we're going to be on next week from the Aalto University main campus. We're going to be speaking to two esteemed physicists from Aalto's historic low temperature laboratory. So definitely stay tuned for that. See you then. Like learning something new? Subscribe to Aalto University's YouTube channel.